Alright, guys, so now that we know what the ribosomal subunit structure looks like, we are going to talk about the next confusing thing, which is a codon table. Now, do we remember what a codon is? A codon is a sequence of 3 nucleotides that identifies which amino acid we need in the next sequence, alright? So, this is a codon table. It tells you what amino acid we need to put in the sequence. So how do you figure out what amino acid you need? You look at the transcribed nucleotide sequence. So let's say that our DNA sequence is DNA. It is G, C, G, T, A, C, G, G, T, and then A, C, T. So let's say this is the DNA. If we want to transcribe it to mRNA, we just need to create a complementary strand, which would be C, since G goes with C, C goes with G, and then you just keep going. So T goes with A goes with U, and then you got U, G, A. Alright, so we are gonna strictly focus on this right here for now. Now remember that I told you that a codon is a sequence of 3 nucleotides, so we are gonna split this into 3. So we're gonna take each 3 nucleotides, we're gonna group them all together. So then we end up with CGC, AUG, CCA, and UGA. Alright? So this is where we start using the table. So let me get this table, move her closer to us. Actually, no, let's drop her down. We're gonna do this down here. So AA is for amino acids. We're gonna figure out what amino acids are gonna be in this polypeptide. So we look at the first sequence. Our first sequence is CGC. So we're gonna go to C. Alright, C on this side. And then the next letter is G. So C, the next letter is G. It's gotta be somewhere here. So we look CGC. It's arginine. I don't know how to say these. Okay, so we just say arg. Okay, but trick question. We actually don't care about CGC because we haven't come across a start codon yet. Meaning we can't start. We need to get a start codon to start. So we're gonna look at our table. Whoa, what is this? AUG is a start codon, which means to start figuring out which amino acids we need to get permission from the mRNA to start in the first place, right? So if the recipe, this right here is in the recipe when they're like telling you about their life story, okay? You don't care about the life story. That has nothing to do with the recipe. You only start the recipe when you click jump to recipe. So AUG is jump to recipe. This is just background information. We don't care about this, okay? So we see AUG. We go to our table. We're like, oh, AUG means start, okay? And start is the amino acid that is methionine. So this down here, the amino acid, is going to be met for methionine, this one. All right, now we can continue with our recipe. Okay, so same thing, CCA, we're going to go over here, we're going to go to C, and then the next letter is C, so it's got to be here. CCA right here, it's proline, so the next one is going to be proline. All right, next one, UGA, we go over here, we got U, we got G, UGA. Oh, what is that? It's a stop codon. That means the recipe is done. So we're just done. We can either write stop here, or we can just leave it blank. And that is our polypeptide. That's it. That's our recipe. We got our cookies right here. So that's basically how you do it. And so now, this is your amino acids. So recap, anything before the start codon we don't care about. We start going after the start codon. So now, how does this whole process, alright, how does that happen in here? Alright, how does that happen? Well, we're going to figure it out, Nog Ops. You will see. I have to get really artsy here, so don't mind the artsiness. I'm going to try my best. So, I got my ribosome. Let me draw my little ribosome here. Like this. Like this. I feel like I should make it bigger. Yeah, we'll go into detail. Yeah, there we go. Alright, and then we have our A site, and then we have our P site. Alright, great. Now, what's gonna happen is we got our mRNA. She's in here. Alright, and our mRNA is gonna have the codons, right? These are the codons. Right here. Alright, so let's use our example up here. So we have a CGC. Let's start AUG because we don't care about CGC. Let's say this right here is a... Oh, we're going to need a way thinner line. Hold up. Alright, so this is AUG. And what do we have for CCA and UGA? CCA, UGA. Alright, perfect. So this is our mRNA. Remember, this is our recipe. We're in the kitchen right now. We're trying to find the ingredients to make our cookies. So, this mRNA is going to go into the ribosome, and then it's going to read AUG. And the ribosome is going to be like, okay, we got to start. So the ribosome is going to read AUG, and it's going to ask its transfer RNA. Remember, tRNA. tRNA is the ingredients, okay? So it's going to say, yo, tRNA, bring me the AUG codon, aka methionine, all right? So we got our tRNA. They're going to do an amazing job. This is your tRNA. It's something that looks like a T, but we're just going to draw it in its simple format. Let's just draw it like this, okay? And this tRNA is going to be carrying the start codon, methionine, okay? So this is going to pull up, and it's going to be going down to the P site. If you remember up there, we said that the P site is where the growing happens, and the A site is where the next sequence happens. You'll understand more later. So this initiator tRNA with the anticodon UAC. Why is it UAC? Because here we have AUG. What goes with that? It would be UAC. So it has the anticodon that matches with this codon. Okay, so this is the initiator tRNA. It picks up the amino acid methionine, and down here it has the anticodon UAC. Okay, so it's prepared. It's ready to bind. It has the ingredients. It's ready to go. So now this transfer RNA, it's gonna go in here. So let's redraw the whole thing. So we got this, we got this, we got this, this, and this. Alright, we got this guy, he's chilling over here. All right. And he has binded to these ones down here. All right, it's binding, and then it has methionine up here. All right, this is what it looks like. All right, our A site is still empty. All right, we got everything. Yeah, let's just label this so we don't get confused. All right, so now the tRNA with an anticodon that matches the next mRNA codon. So what's our next mRNA codon? Do we remember? We'll have it right here. It's CCA. So it's got CCA, and then we said this is AUG. All right? So the tRNA with an anticodon that matches the next mRNA picks up a specific amino acid and binds to the mRNA at A site. So remember how I told you that P site is where the connection is happening, A site is just preparing the next ingredient, right? So like in this here, we are measuring out the ingredients. So say it's 1 cup of flour. You're putting the flour in the cup here, and then you're putting it into your mixing bowl here to get your cookies, all right? So we're slowly adding our ingredients here. So with that being said, we said that a tRNA, so we got another guy, tRNA, with the anticodon that matches the next mRNA. So CCA, what would be that? It would be GGU. GGU is what would match it. So it would have this little anticodon here, and then it would be carrying our next amino acid, which was proline. Let's double check. Yes, proline. Whoops. So this is going to be carrying proline. And this thing is going to go right down here. So let's just erase this because I don't want to redraw this. This is going to go right here. All right. We got pro right here. And then this is binding to that. It's reading it all. So this is what it looks like in the second stage. And I just realized that I completely forgot about the stage names. So let's go back. This stage right here is stage number 1. And this one is called initiation, because it's where everything starts. Remember, the initiator tRNA, it picks the codon, it has the anticodon that goes with the start codon, and it brings methionine over here. And then this step here, I'm gonna match the colors. This is elongation. Elongation has many different steps. First one was codon recognition. So that's when this tRNA right here recognized the next sequence. So let's do like little sub things. So codon recognition. All right. So that's when this guy, the ribosome read this, and it told this guy, yo, we need proline. Proline is coming up next. So this guy came here, brought it here. That's codon recognition. It recognized the codon. Now that they're both over here, all right, we got methionine, we got proline. What do we do next? We need to connect them together. So what's going to happen is this guy is going to move over here. All right, the green, we don't need her anymore. We don't need the tRNA. It dropped off the ingredients. So this is going to go over here. This is going to go away. So we're basically going to add them to the mixing bowl. And to make this less confusing, let's draw it again. All right. Boom, boom. So, can't forget the mRNA down here. So this guy right here, he's gonna go right here. Okay. And when he goes right here, he's going to have two things attached to him. He's going to have a thymine, and then let's do a triangle. Triangle for proline. Alright, he's going to have it like this. They connected. And then this guy right here, he's just going to exit from here. Alright, this is our old guy. You know, he dropped off the stuff. It's like when you put your measuring cup, you know, you measured out your flour, and then you put your measuring cup in the sink. This guy's going to go to the sink. Alright, we don't need him anymore. This was our initiator tRNA. He's gone. Now, the process, it's the exact same as here. So, what's going to happen is, oh, let me forgetting again. This process right here, this is, wait, hold on, missed a couple. So, when these two connect, alright, that's called peptide formation. Peptide bond formation. Peptide bond formation. Because when two amino acids connect together, that is called a peptide bond. So when two amino acids connect together, that is called a peptide bond. And then the whole idea of this guy moving over to here and this guy leaving, that is called translocation. Alright, so that is what happens in elongation. So in elongation, the A site, let's use this one, it's more fun. The A site recognizes the next codon. It tells the tRNA, yo, bring us proline. You're going to be next in the sequence. We need you here. So this brings proline, and then this guy attaches here, and then this moves over to here. Alright? This guy attaches, this guy moves on over here. When they move on over here, this guy right here, he leaves. Alright? So, codon recognition, peptide bond formation, translocation. Alright? Translocation. So, this process just repeats itself. So now that A site is empty, A site is like, yo, we need someone else. We have our next sequence, where our next sequence was UGA. So we got UGA. So the ribosome is going to be like, what is that? Let's look. What is that? Oh, UGA is a stop codon. That means we're done. That's it. This is our protein. We're done. And so it's going to tell everybody, yo, stop. We're done. And this process right here is called termination, because we terminated it. Termination. So this right here, this guy right here, it's gonna, okay, that did not work how I thought it would. But this guy right here, okay, it's done. Our protein is done. So this is called a polypeptide. The polypeptide and its tRNA, they're gonna detach from the ribosome. Okay? And then this ribosome is going to split up. Alright? It's going to release the peptide. It's going to release this. And then it's ready for another mRNA to go in and translate it and all of that stuff. So when we hit the stop codon, this is going to detach. It's going to leave. And then the ribosome is going to be ready for another set of instructions or for another recipe, okay? So our cookies are done. We took them out of the oven. We're eating them outside of the kitchen and enjoying them. But after translation, there is something called folding. And if these polypeptide, this is a polypeptide, if it does not fold correctly, it will not work normally. And that's when you get ill. And it will cause illnesses, right? So that's like you let's say you didn't take the cookies out of the parchment paper and you ended up eating the parchment paper, you're not going to be good. So think of folding as you taking the cookies off of the parchment paper, or you putting icing on the cookies, whatever makes you happy, that, and will not get you sick, okay? And then you can enjoy your cookies nicely. And that is protein synthesis. So this process just keeps happening over and over again in your cells using the mRNA. What do you think, Nog Ops? Do we understand protein synthesis and translation? I think she does. And that is it for protein synthesis and translation. Much appreciated, Nog Ops, and I hope you understand. And see you in the next lesson.